my wonderful people, to today's wonderful edition in which we will be looking at what we call the speed time graph. So this is a very important concept in mathematics paper 1. So we are considering the question from 2017, and it says, the diagram below shows the speed time graph of a car journey. This is the speed time graph of the car journey. So the horizontal axis is actually for time in seconds, and the vertical axis is for velocity in meters per second. So now the first question says, find the acceleration during the first 5 seconds. So to find the acceleration in such kind of a graph, you simply bring in the formula for acceleration. And the formula says acceleration is equal to final velocity, which is capital V, minus initial velocity, which is beta u, divided by time. So coming back to our diagram here, the final velocity will be from here to there. This is actually the acceleration. This is the constant velocity, and that is the deceleration or the negative acceleration. So the final velocity, which is v, will be the point where the acceleration is ending, which is here. So the figure is 30, and initial velocity is where it's starting from, which is 0. So this will give us final velocity 30 minus 0 divided by time. The time which the car took to reach that velocity of 30 meters per second, the time was 5 seconds. So this is 5 seconds. And acceleration is equal to, this is 30 over 5. And dividing 5 into 30, we are getting 6 meters per square second. This is the acceleration that we are looking for. As simple as that. So, shall we go to question B, which says, if the total distance traveled was 825 meters, find the value of t. So now, they have given us the total distance which the car traveled from here up to the end there, which is 825. So to find the value of t, what is important to understand here is to know that area is equal to distance. This is the concept in speed time graph. So the area is equal to the distance covered. So we are saying to find the value of t, we are going to consider the shape that has been formed by the journey of the car. And looking at the shape here, it is actually a trapezium. So since we are saying the area is equal to distance, therefore we bring in the formula for area of a trapezium, which is area is equals to 1/2 in brackets a plus b, then multiplied by the height. So area is the same as distance, meaning where there is a here, we will put the distance given. So the distance is 825. So then we have 825 is equal to 1/2. The a and the b are the two parallel sides in a trapezium. So this side and this side, the two sides gives us the a and the b, or the values of a and b. So from here to here will be the a. That is, here it is 5 down here, and here it is 15. So we get the difference between 5 and 15, and that will give us a 10. So a will be 10 plus b will be the t, because we are saying b is from here to there, which is t. So b is t here, close the bracket. H is the height of the trapezium. How high is this? So that final point, we get the figure here, it will give us 30. So height is 30. Then at this point, this 1/2 will multiply with the 30. So we are saying 825 is equal to, 825 is equal to half multiplied by 30, we are getting 15. 15 will multiply what is inside here, that is 10 plus t. Then we expand, of course, by using 15. So we have 825 is equal to 15 multiplied by 10, that is 150, plus 15, that is t. So at this point, we are going to group the items, and we have 825 minus 150 equals 15t. So subtracting 150 from 825, we are getting, this is 675 is equal to 15t. So to find t, we divide throughout by the t, by the 15, which is the 5 and the 5 will divide. Therefore, t is equal to, dividing 15 into 675 gives us 45. So 45 seconds is the value of t. So that has been found. Then coming to the last question, which says find the value or find the average speed for the whole journey. So to find the average speed for the whole journey, we bring the formula for average speed, and the formula says speed is equal to distance over time. So speed is equal to the distance we are already given as 825. So we simply write 825 divided by t, which is time. Time will now be the same figure which we have found on t. So you can see that these questions are connected. The moment you get the wrong value of t, even here it will automatically be wrong. So t is 45. And then speed is equal to, so in paper 1 we don't use calculators. If figures are big in this manner, you can still reduce them. There's no problem. So in this case, we can use a 5 to reduce this. So say 5 into 825, we are getting, this is, here the 5 there is 1, 6, 5, 165. Divided by 5 into 45, that is 9. And finally, we divide 9 into 165. So therefore, speed is equal to, dividing 9 into 165, we are getting 18.3 meters per second. Those are the units for speed. So remember, this comes in paper 1, and hit the bell for new videos of such kind. If you have not yet subscribed, please do so. See you next time.